Joining us now is an amazing visionary who is no ordinary man. He is somebody whose name resonates globally with every member of the DevOps community. He is a CEO and principal consultant at Engineering DevOps Consulting. With over 40 years of experience in architecting, designing, developing, and managing high-performance solutions for IT and engineering framework globally, he has authored Continuous Delivery Architect course and the DevOps Test Engineering course for the DevOps Institute. Apart from being a regular DevOps blogger for DevOps.com, he is also a life senior member of the IEEE and has been awarded the most outstanding engineer by the IEEE. Today, he's going to give us a detailed walkthrough on continuous security maturity assessment. With that, ladies and gentlemen, please put your hearts and souls together for the one and only Mr. Marc Hornbeek.
Hello. Hi, this is Marc Hornbeek. I am thankful to be participating in the DevOps India Summit 2020 again. I really appreciate the opportunity, Naladri and team. Another great event. I was thankful to participate in the first and the second, and now this third is looking like another great event. I'll be talking about continuous security maturity assessment, essentially an approach that I use in my consulting business to help people understand where they are with continuous security and how to evolve their organizations towards more mature continuous security. I'll introduce myself briefly. I am Marc Hornbeek, known as DevOps the Gray. I'm CEO and principal consultant of Engineering DevOps Consulting. I'm an analyst for the Accelerated Strategies Group, an ambassador and course author for the DevOps Institute, a blogger on DevOps.com, and author of the book you see in this picture here called Engineering DevOps. But without further ado, let's get started. What you'll learn in this talk, I'll talk about what is continuous security, why is continuous security important, understand a blueprint for continuous security best practices, how to model continuous security maturity, how to self-assess your continuous security, how to accelerate and scale your continuous security. And I'll talk about a more detailed model that I use in my consulting practice called the 9 Pillars Deep Dive Security Assessment. There is a white paper on my website at www.engineeringdevops.com, available for free, called Engineering Continuous Security. And hope all of you will learn something from this talk and find some of the materials available, like the white paper and so on, that I'll talk about further, useful for your own needs. So what is continuous security? I use the term continuous security more than I use the term DevSecOps, which is really, encompasses that. DevSecOps, as it was at least originally defined, really addressed the cultural aspects of introducing security as code, whereas there was another term that's not used so much lately, but called rugged DevOps, that is more about engineering security into the design and deployment processes, so tooling and some of the technical aspects. So in my mind, continuous security encompasses both DevOps and rugged DevOps. Why is it important for DevOps? Well, in general, security is important, but when you're talking about DevOps, you're talking about ways of accelerating deployments and making lead times for development and deployment quicker. So that has the potential for causing new problems that could exacerbate security issues such as loss of sensitive and proprietary information, disruption to operations, financial losses related to restoring systems, and generally speaking, harm to an organization's reputation. So, all of those security concerns are certainly valid and important for DevOps as well, and even more so in the sense that security is being accelerated through the acceleration of the DevOps processes. How do you do this? What are the challenges? First of all, security is often seen as an inhibitor to DevOps agility because you sort of want to go faster, but security wants to be careful and maybe slow things down. Security infrastructure has generally not been software defined from the get-go or programmable, so it makes it somewhat difficult to integrate security controls into a DevOps style workflow. at least in an automated, transparent way. And modern applications, generally speaking, if you look at the content of them, are largely assembled from open source or other sources rather than developed. And developers often just download and use components that have known vulnerable open source problems and frameworks. So all these things are part of the challenges of continuous security that need to be overcome with a really good DevOps practice. How does security work? Well, this is a big eye chart, so I'm not going to go through all of it in the time frame we have. We just don't have time to go through all of it, but I'll give you the idea. But this is what I call my continuous security blueprint. It's available on my website. At the heart of it, you have a DevOps blueprint that has all the different layers and breadths and depths of DevOps. At the top, you have the DevOps value stream management, from planning through to operations, application release automation and orchestration, especially the CI/CD pipeline aspects. And at the bottom, you have infrastructure. And overall, you need to have governance, continuous security, site reliability, even disaster recovery. So there's some big picture items that all of this applies to, that big picture. If you think about security, you really have to be concerned about all of those things. And if you go around, the boxes on the blueprint, starting with planning, there are security requirements from business functionality, security stories in the backlog that all have to be considered. There's various tools available to help with that. Cyber Planner is a good one, ServiceNow, Jira. If you then move into design, threat modeling is valuable. Securing by default designs, so security services and frameworks. Making sure that you're scanning open source before you start using them. Tools such as Continuum Security, Threat Modeler, Black Duck, there are various tools available to help with that part of the process of continuous security. Code and testing is another area after design. You have development standards that consider security, peer reviews, static code analysis, unit tests, software supply chains, data masking, web code scanning, and so on. Again, there is a lot of tools to help with this. I'm not going to go through in this detail all these boxes because we just don't have time, but you get the idea. Each box tells you kind of what continuous security is concerned about and talks about some of the tools that are available to help. So, if you just go around the boxes themselves, after code and test, there's commit and merging, and then building and testing, and then producing artifacts that are release candidates. Then acceptance testing at the system and user level, approving releases, deployment to production, actual deployment, post-production testing, such as dark lines tests. And of course, there's things that are overriding that, so value stream management, release automation, and or infrastructure aspects. So all of these things you need to consider in your strategy. Your strategy needs to consider security aspects of all of these things. And this blueprint just gives you a one-page reminder, if you like, what to think about. Maybe some of these things are not so important for your particular application, and some of them are more important. But in a nutshell, these are things that you should consider for continuous security. So generally speaking, if you do this, then DevOps, rather than being, a challenge, can be actually an opportunity to integrate security and reduce risks by integrating security into the pipeline according to, good engineering practices. So the rest of this talk will largely talk about, what are the practices, beyond tools, which are probably at least as important, if not more important, than the tools themselves. So when I talk about maturity, I have a simple model and a more complex model. I think people tend to understand the simple model easier, but and then you can dive into a more deep dive model when you want to get into details. But in general, for security, I talk about 5 maturity levels in my simple model, starting with chaos. Continuous integration is level 2. Continuous flow, which is the first way of DevOps. Continuous feedback, the second way, and finally, at the highest level of maturity, you've got continuous improvement. All of that needs to be, balanced. Solutions for these things need to be balanced. There's at least 2 major dimensions. There's people, process, and technology, which is sort of the top level of the blueprint I showed. And thus, things need to be balanced with applications, pipelines, and infrastructure. And all the practices need to be, compatible with whatever maturity level you're at. There's really not a whole lot of point of having, let's say, a level 4 capability for one thing and only a level 1 for other things. You want to have solutions that are balanced so that at any point in time you've got a really solid, framework and capability for your continuous security solution. Okay, so let's talk about these different levels for continuous security. At level 1, chaos. Every level, there's people, process, and technology aspects. So at chaos level, you've really got siloed teams, very little knowledge of continuous security, a lot of blame and finger pointing going on. At the process dimension, security is not really part of planning. There are a few security checks as part of the DevOps pipeline. Technologies, missing tools to monitor security of applications, pipelines, and infrastructure. At least some of them are missing. The typical outcomes that I see in my consulting work is, you just don't know what's going on. So the general idea is, hey, is there a security problem? You don't even know, really, because you don't have the ways to monitor it or determine that. And security problems tend to be a surprise. You're missing security checks. Responses to problems tend to be very slow because you don't have the data to analyze readily. And there's a lot of blame and finger pointing. So that's what level 1 looks like. Level 2, you're really starting to get things a little more organized, at least at the front end of the value stream or pipeline. In this case, you've got people that have some knowledge of continuous security, and some security tasks are being, appearing in the backlogs as important things to plan for. Ad hoc security training is in place, and there's some security consultants at least available that you can talk to, if not in the organization, but at least available somewhere that you can communicate security concerns with. At the process level, you may not have an end-to-end security plan, but at least you've got some repeatable build processes with security checks at the front end. Most of the commits from development pass security code static analysis tests before they're considered part of the trunk branch. And generally speaking, secrets are being vaulted by this time. You're starting to get control over how you're handling secrets. The technology, certainly you have strong version management at this point, at least for the code and pre-flight and before it commits. And commit processes include security checks like static analysis, whitelist tools, security test tools. And generally speaking, you've got very painful but repeatable releases. So in the consulting work, I find the question is, what happened? At least that something happened. You've got enough in place that you can detect something is a concern from a security point of view. You may not know exactly what it is, but at least you've got some pointers to say, yeah, I know I've got a problem to look into. And generally speaking, at least from a release point of view, you've got a reaction to what isn't known, somewhat chaotic. You don't have an end-to-end pipeline security capability, and the results generally have to be correlated manually. But it's still a lot better than level 1. Level 3 is really where you're getting into continuous flow in the first way of DevOps. This is a more, if you like, professional, comprehensive, complete security, continuous security situation. In this case, leaders articulate a DevOps security vision. There's cross-functional participation in security aspects. Continuous security skills exist, and there's a training program that includes security and risk management. Processes are now more end-to-end with CI/CD pipelines and infrastructure availability. Security vulnerabilities are visible. Security standards and protocols are in place, and security event response time metrics are in place. There's a lot more tooling, so the tool chains across the end-to-end tool chain have security tools being driven by APIs, and tests are available that are targeted specifically to different security standards that are relevant for the application. You have signed artifacts in place for things like the containers and other things that are being brought in as artifacts for deliverables. The event streams are filtered for applications, infrastructure, and security pipeline and pipelines so that the right people get the information for security events at the right time. And release and deployment metrics have security built into the the decision process for releasing and deployment as much as possible automated. In this case, what happened. The activities are generally speaking, how did it happen? Trying to get to the root cause, but there's a lot of filtering and alerting going on, and so you're pretty sure, when a security event occurs, you get a warning, and there's still some activity required to, dive into that and determine, what to do about it. So, there's generally speaking, it's proactive security test results are integrated into one place for analysis. So, the analysis itself may be less automated, but at least you've got a professional, competent, end-to-end continuous security flow. At level 4, we're getting into a more advanced level. Again, in my consulting work, I don't see this as much. Most enterprises haven't got to this level yet. Some have. Certainly some of the unicorns generally have. Here are the people aspects. You've got collaboration using secured metrics. So a lot of collaboration, a lot of cultural aspects that are really thinking about security up front. There are goals in place. So things like service level indicators, objectives, and agreements, to use terminology from site reliability engineering, but there are metrics in place that really are targeted for security that can be used to gate a release. Mentors and guilds are in place for mastering security. There are recognition programs that include security concerns. Processes tend to be very proactive with trend analysis and visibility for security. It's more than just reporting data, but actually some analysis going on automatically. The warnings are available to trigger actions, not just to say, hey, something happened, but actually drive actions. There are some of the advanced security methods like red, blue teams being managed and scheduled frequently to give further feedback. And the technology, you've now got apps, pipelines, and the infrastructure being instrumented deeply for security. A lot of infrastructure and configuration as code to make sure that when things are tested, they can be locked down, or at least repeated without the concern of bringing in new security vulnerabilities. Releases are automated with security policies, and value stream analytics exist for the end-to-end security environment. So in this case, the typical outcome is you've got a more predictive situation. The type of comment you'll hear is we're going to have a security problem because the data tells you that, and you start diving into it ahead of the problem actually occurring. So a lot of security predictions, automated security analysis, and fast response to security problems. Generally speaking, there's a high level of confidence in achieving security-related SLAs in production. The final level, which is the third way of DevOps, is it's kind of the forever level. If you get there, continuous improvement, continuous experimentation, and trying to figure out ways to make improvements. So at this level, people are involved in a lot of innovative experimentation with new security ideas, methodologies, high level of confidence. SREs are generally available within development to help steer what is important from a customer user viewpoint and business viewpoint. End-to-end security experience is relevant and prevalent in the organization. Processes are consolidated with security metrics. There's a lot of monitoring, not just data, but even the outliers, and not just the averages. So you're looking for more sophisticated security possible concerns. A lot of insights, so the idea of observability, going beyond just monitoring of data streams, but actually making insightful decisions and analysis into the data that's being streamed, and that being made to stakeholders properly ahead of time. Security chaos testing is a relatively new idea, but that's also something that would be an example of what at this level people would be looking at. At the technology level, you're looking more at, you've already got the tooling in place. You're looking more at things like more advanced security algorithms, synthetic security monitoring, where you've got actions being taken and proactively looking for security issues ahead of the natural events. Excuse me. And generally speaking, you're looking at things like intelligent security analytics, like AI SecOps. Typical outcomes in this case, you're really looking ahead here. Here's a fix for the predicted security threat. You've got a self-correcting situation, very high confidence, highly innovative, and preparing basically for what I call the sixth way of DevOps, the fourth way of DevOps, which is you can build a platform for what's not only continuous improvement but autonomous continuous improvement, where the system starts improving itself. Okay, so that's kind of like how I look at the maturity of DevOps, continuous security, and if you put it all together in one chart, you can essentially use what I just showed you as an assessment model. If you take the same data and apply the 5 levels against people, process, and tech, you literally can, just say, okay, where am I? Which boxes in this chart most relate to my situation, and you can kind of give yourself a score. It's a pretty simple approach, right? And it's not all that refined or accurate, but if you just want a quick view kind of where you're at in terms of security maturity, this is a simple way to do it. There is a white paper on my website, as I mentioned, that explains this. And also there's even a little self-assessment tool available on engineeringdevops.com that's pretty much the same thing, just as a little Excel tool, just to help you if you want to use that. I've used it with some clients in a first touch situation. It's not exhaustive, as I say, but it's handy. This is the actual tool where you can sort of say, in this case, the person put a 1, level 2 for people and process seemed to best match their situation, and level 3 for technology, which ended up being a score of, basically an average of 2 if you round it down. So they're at level 2 basically, and they would like to get to higher levels, maybe at least 3, if not 4 or 5. Again, it's a very simple rudimentary tool. You can literally in just a few minutes figure out where you are in your maturity curve, and then decide whether you want to go to a deep dive assessment or not, and figure out what your roadmap could be to get to a higher level of maturity. Okay. I will point out, by the way, that in most of the assessments I've done, this is not atypical. A lot of organizations are kind of at level 2, level 3 level. Very few really at level 4, level 5, except the unicorns, at least in the ones I've been involved in. Maybe it's because the people that tend to call consultants are ones that do need help. I suppose that's probably a biased view of the population in that sense. So what do you do with this? Well, if you do know where you are at, let's say you're at level 1 chaos, how can you move up the maturity level to the higher levels? So if you're at level 1, you're really looking at putting in place development and CI security tools and the associated processes and cultural aspects. If you're at level 2, then you're really looking at putting in place more of the CDs, deployment, and other aspects in delivery and deployment into your processes. If you're at level 3, you're looking more at advanced metrics, and if you're at level 4, you're looking for optimizations. I will tell you that it's been my experience that going from one level to another is not simple. There's an investment of tools and people and process changes. These things all take time to acquire, install, influence, and implement, test, validate, operationalize. So going from one level to the other, it's usually 6 to 12 months to really do a proper job of getting from one level. I've seen it done faster when the entire organization is driven by, let's say, senior management with a big budget. But typically, going from a level 2 to a level 3, it's a 6 to 12 month effort. It's been my own experience, just as a reference point. Okay, if you do that, basic maturity level, and you wanted to go deeper, I actually do have something I call a deep 9 pillars deep dive, where I go to I talk about security in 9 pillars. The pillars being leadership practices, collaborative culture practices, design for DevOps practices. So things like how do you design your applications for security, continuous integration, continuous testing, continuous monitoring, infrastructure on demand, delivery deployment, and then security itself is a pillar, those things across all the other pillars. So these are a set of practices. In this case, I loaded the tool, it looks like with, looks like 50 practices. Depending on the client, I have different ones I would load, depending what's important. But the idea is that, by going through this level, and this is a real outcome, by the way, with an actual client. Can't name the name of the client, but it was a large enterprise in the U.S. And we found out that the highest gap practice area was the delivery and deployment area. So they were sort of at level 2, trying to become a good level 3. What the tool does is it allows the client to score the importance of the different practices and then the practice level they're at on a scale of 1 to 5. And then there's a gap score calculator. There's a proprietary algorithm I use to help you figure out, where are the areas of highest importance. And here we had, a gap of 9.8 out of a possible gap of 15, which is somewhat concerning. Their delivery deployment practices were not up to speed. There's also a radar chart that kind of gives you a visual view of where you're at. And they also had concerns. I guess the second ranked gap area was the security practices themselves, and the third was monitoring. So it just gives you, in a quick visual way of saying, okay, where do we need to make improvements relative to their own view of importance and practice level that our industry known good practices for continuous security. Okay, that's basically what I had to say about continuous security. There's a lot of information available. Even the more detailed 9 pillars deep dive assessment model is on my website. You are welcome to contact me anytime at my email address, mhornbeek@engineeringdevops.com, or drop into my website. Certainly download a copy of the Continuous Security white paper, and or you can get a copy of my book on mybook.to engineeringdevops.com. Again, I'd really like to thank Naladri and the DOAS 2020 team for having me the opportunity to give this talk. I hope you've learned something from it, and I hope you do take the opportunity to follow up with me if you find anything here that could be of interest where I could help you.